June 2020, paper 6, variant 3. Okay, first question talks about a sample of rock containing sodium chloride and sand. The first thing that pops into your mind is that sodium chloride is soluble and sand is insoluble. He's doing a method called solvent extraction method to obtain pure dry crystals of sodium chloride. Okay, this is the step. He first crushes to increase the surface area, and then he dissolves the sodium chloride, then he removes the insoluble sand by filtration. Name the apparatus labeled A. Take care, this is a mortar. Take care from the spelling, and it's not a mortar and pestle, it's only a mortar. This is the pestle. Explain why the mixture is heated and stirred up in step 2 to speed up dissolving. He's trying to dissolve sodium chloride, so to speed up the dissolving. Speed up takes the mark. Then name the apparatus labeled B. This is a funnel. A filter funnel is not accepted. This is only a funnel. Okay, this is called a funnel. This is called a filter paper. Don't mix them up, please. State the scientific term for the sand left in the paper: residue. Of course, if he asked about this, it is the filtrate. Describe what the student must do to obtain crystals, the steps of crystallization. Okay, take care. Here, he must take this, put it in an evaporating dish, and then heat. Okay, if I say heat the solution till crystallization point. Okay, then cool. I'll leave it to cool down. Filter, wash, and dry the crystals between two filter paper. Okay, it's important to say the three final steps together. Cool, then filter, wash, and dry. Okay, 1 mark for heating the solution, 1 mark for crystallization point, 1 mark for cool, filter, and dry. You must say cool, filter, and dry to take the 3rd mark. Second question is titration. It's a neutralization reaction, and the student is measuring the change in the temperature. He used a polystyrene cup, which is good because polystyrene is a heat insulator. He used a measuring cylinder, which we could use if he asked for an apparatus improvement. He should have used a burette or something more accurate. Then he did the experiment. It's very important to notice what is he changing from one experiment to the other. It seems that he's changing the volume of sodium hydroxide and the volume of hydrochloric acid, but take care, the final volume is always 50. The final volume is always constant. He's just changing the volumes while keeping the final volume constant. Then he asks you to take the readings. Of course, the volume of dilute hydrochloric acid, you just get it from the question itself: 45, 40, 35, 30, 20, 15, 10, and 5. Okay, the highest temperature reached 23, 25, 27, 29, 30, 28, 26, 24. Each mistake is for a mark. You deduct a mark. Okay, this was one of the most important graphs that came in paper 6. I'll erase this just for now. Okay, he asked for drawing 2 straight lines. Straight lines, you must use a ruler. If he said straight lines, you must use a ruler. Okay, and then you need to extend your straight lines so the lines cross. So this is the first line, okay? And this is the second line, and they cross and meet here. You must draw it like this, okay? They must meet here. This is for 4 marks. The plotting of the points is for 3, and extending the lines to meet is for 1 mark. Then he asks you to use your graph to deduce the volume of sodium hydroxide and HCl that react together to produce a neutral solution. But take care that he gave you the answer in this heading when he said that the graph where the 2 straight lines cross is where all of the sodium hydroxide reacts with the hydrochloric acid. So he told you that this point is the point of neutralization, where all the acid reacted with all the alkali. You need to get to this point, read the x-axis, and take care of the volume needed. It will be around 26 centimeter cube if your graph is accurate. Then he's asking about the volume of hydrochloric acid. Take care, because so many of you get this reading and write it down here. You write here 31.4. No, he wants the volume of hydrochloric acid. You know from the question that the total volume is always 50. Okay, and if you come back here, he's always adding these together, but the total is always 50. But you now said that the volume of sodium hydroxide is 26. But definitely the volume of HCl is 50 minus 26, which is 24. Double I, he wants you to use the graph to determine the maximum temperature reached. The maximum temperature is at the point of neutralization. You'll just read the y-axis. Take care, this will be 31.4. Each small square is worth 0.2. 31.4, of course, degrees Celsius. Okay, which solution, sodium hydroxide, the HCl, was the more concentrated? This is a very tricky and important question. You needed 26 centimeter cube of sodium hydroxide and 24 centimeter cube of HCl. The solution that you required a lower volume of was more concentrated because it neutralized the other, requiring a lower volume. If he needed 25 and 25, this would have meant that they both have equal concentrations, but he needed more of the sodium hydroxide because it's less concentrated, or we can say that he needed less from the HCl because it's more concentrated. So the answer is that the acid is more concentrated because a lower volume was used than the sodium hydroxide. Okay, question D. On the graph, sketch the lines you would expect to obtain if a copper can was used instead of polystyrene cup. Copper can. Take care. This is again a tricky question. Copper can means that copper is a good heat conductor. So heat will be lost to the surrounding. Okay. So while measuring the temperature changes should be lower. But take care, you should draw a line that is below the first one, but the two lines should meet at the same point because you didn't change the concentration. So the volume where neutralization happens will be the same. Okay, so two lines, straight lines drawn with a ruler, okay, that meet below the first point of neutralization. This was a very good question. Okay. Then he's asking in E, give one advantage and disadvantage of using a burette. Of course, a burette is more accurate, but it's slower. The pipette has the same advantages and disadvantages. Okay, how to know, how to make the experiment more reliable? Repeat, take average, and compare. Or repeat and compare the results. Question 3, cations and anions. Okay. In question 3, he has two solids, N and P, and he's analyzing both solids. He didn't say anything about them, but he gave you the tests and the observation. Take care. When he added sodium hydroxide, white precipitate, so we're thinking aluminium, zinc, and calcium, but the precipitate dissolved, so we're not thinking in terms of calcium anymore. Type. In case of aqueous ammonia, white precipitate dissolved. If it dissolves in both, there's only one cation that does this, zinc. Then he's using aluminium foil, which when you see على طول, you think in nitrate test. Okay, sodium hydroxide and heat, and yes, effervescence was seen. Ammonia was produced, which turns litmus paper blue, which means nitrate was present. So you know the cation and the anion now. You can easily continue the question. Okay, the gas given is ammonia since it turned litmus paper blue. Identify solid N. It is zinc nitrate. Then solid P, it's potassium iodide, and he wants its appearance. Of course, it's a white solid because it's a group 1 solid. Flame test with potassium as the cation will give me a lilac flame. And then he added silver nitrate solution, which is the test for halides. We have potassium iodide with silver nitrate gives you a yellow precipitate. Take care, silver nitrate is used to test for the 3 main halides, and chloride, bromide, and iodide. Gives white, creamy, and yellow precipitate respectively. Double I, he says that he used barium nitrate solution and few drops of nitric acid. To P, barium nitrate is the test for sulfate. Okay, take care, no change will occur because there is no sulfate. Then he added aqueous bromine. Okay, aqueous bromine was added to the third portion of solution P. Take care. potassium iodide and you're adding bromine, a displacement reaction will take place. Potassium bromide and iodine will be formed. Okay, iodine is a solution. So iodine, sorry, is soluble, and potassium bromide and potassium iodide are solutions, and therefore iodine will dissolve in the potassium bromide, giving a brown color. The solution turns brown. Of course, orange is accepted. Okay, this wasn't an easy question, but take care. Iodine produced as a solution has a brown color due to the displacement reaction that took place. Finally, the experimental design. It was an easy one, and there are several ways for solving this experiment. Okay, he says that there are two brands of washing powder which are made of sodium carbonate, okay, metal carbonate, so it's an alkali. And then he said that it's soluble in water and reacts with sulfuric acid to produce a gas. Plan an investigation to know which one of the washing powder has the greatest percentage of sodium carbonate. The easiest and the most straightforward way is to measure the total volume of the gas produced. If it contains more sodium carbonate, it will produce more gas. Okay, يعني please يا شباب be as simple as possible في الاكسبيرمنت. بتطلع جاز، هقيس الفوليوم بتاعت الجاز اللي فيه صوديوم كربونات اكتر هيطلع جاز اكتر. يبقى the gas volume method, simply get a known mass of sodium carbonate from the first washing powder, put it in a conical flask, add acid till its excess, وتقدر تعرف when no more bubbles appear because carbon dioxide will stop. Of course, you must say that you will collect the gas by a gas syringe, and you will measure its volume. Every one of this takes a mark. You will collect the gas. Whenever you're collecting something, mention the apparatus by a gas syringe and measure the volume of the gas. Repeat the experiment with the other cleaner. The one that produced the largest volume of gas has the most sodium carbonate. Okay, if you want to imagine the experiment, it's like this: a conical flask with a gas syringe connected to it and a bung here to close, and you're just measuring the volume of the gas produced. Okay, the second method is the titration method. You will get a known mass of the first washing powder in a conical flask and you will dissolve it in water. Most of students forget that he said it's a solid, and to do titration you must have solutions. So you will dissolve in water, then add the indicator. Please never use the universal indicator in a titration. It gives too many color and makes detecting the endpoint difficult. And then you will add the acid from the burette till the indicator changes color. Record the volume used of the acid. Repeat with the other washing powder. The one who required largest volume of acid has the most sodium carbonate. A third way for solving this experiment would be measuring the mass loss. Okay, you will do the same experiment as the gas volume, but you will just measure the mass of the reaction container, of the reaction mixture. Okay, you will put a cotton wool to allow gases to escape, and you will place the whole experiment on a balance, and you will measure what happens to the mass, and the one of the experiment which has the highest loss in mass had the most sodium carbonate. The washing powder which had the highest loss in mass had the most amount of sodium carbonate. Thank you. This was June 2020, paper 6, variant 3 by Mr. Marco Medhat.